and then share this screen. So hopefully you see the right screen.
Mm-hmm.
Sorry if I from time to time look at this direction because my presentation is rendered on this screen.
That's fine.
Okay, so thank you very much for joining. This is the kickoff meeting of the Semantic Industries W3C Community Group. As you may possibly have known, this community group has been created, I guess, 2 years ago or even before that. So we had a lot of offline discussion with different groups to see how do we want to steer this. And now this is the first official kickoff meeting. So just as a matter of organizational thing, I invited everybody. There were some responses, and from those responses, some people agreed to join. It was like 5 people were expected to be in the meeting today, but we are 3. But it's good to have like core to get started. Here we quickly go through a round of introduction just between us, and then I will explain what was meant with this semantic industries without taking any side. This is just the thing that we decided to do in some of the project meeting in EU projects, but this is not set as an agenda at the moment. So we always have the opportunity to steer the agenda toward the things. As far as we actually keep this 2 keywords, semantics and industries. So that's it. Let's see if you still see my screen. Now you should see the participants list.
No.
No, we can see.
Okay, sharing was disrupted. I don't know why. Okay, so I'm sharing again.
Yeah. Yeah. Yes.
Okay. So sorry, I don't have all the names, especially yours. Then I will go through the intro by starting from myself, and then pass it to you. Please explain it possibly in a way that an offline audience can also understand it.
Mm-hmm.
Okay, so my name is Javad Chamanara. I'm working at the L3S Research Center that belongs to the University of Hannover in Hannover, Germany. I have a PhD in computer science, and I'm doing my postdoc here. So basically, I'm doing some sort of like proposal writing, grant management, project management, and so on. The core activities that I am involved in are semantification of industrial data or preparing them for semantic usages, then applying machine learning algorithms on large scale and also possibly industrial use cases. That's it. And then to try to optimize mainly for energy, if possible, using machine learning techniques. So if there is a use case that I can apply some sort of orchestration, prediction, and so on, to first of all analyze for energy and then optimize for energy, that would be of my interest. That is from my side. At the moment, I am the chair of this community, but there was no election, as you can guess it. So when we actually attract a critical mass, possibly we can go with some sort of election or some sort of other democratic way of selecting people to actually to have a formal, let's say, assembly and also a democratic assembly for the community group. That's from my side. Go ahead, please, Felix, and then we can continue.
Okay. Yeah. Many thanks, Javad. So my name is Felix Engel, which essentially translated to English would be angel, but indeed I'm spelled with an E, not an A. but it doesn't matter. However, I worked for the TIB, Leibniz Information Center for Science and Technology in Hannover, Germany. There I'm employed as a project manager, and more specifically, most of the time I work for as a terminology service coordinator. We bring in a terminology service that, that serves kind of as a hub for community work for ontologies in various domains. And yeah, so for my background, I have lots of experience working with ontologies and semantic web applications in applications of various fields. I did a lot of research and management. And before I came to TIB, I have worked for a university in a postdoc position. Well, yeah, that's a bit about me.
Okay, thank you very much. At the moment, I'm just updating the slides as you see, just to have everything recorded. Thank you for your patience. Abdelhak, can you go ahead, please?
Yeah, so I'm Abdelhak Khemiri. So I made an industrial PhD in the semiconductor manufacturing domain, and after that, basically, I was in postdoc at the École des Mines of Saint-Étienne, and there I essentially work around semiconductor manufacturing modelization and simulation, but also with all semantic modeling of the semiconductor domain. And I'm actually working on the SC3 project with Felix.
Okay, great. So just one thing, I'm not sure is it still recording or not. Do you see any sign of recording on your screens?
It is recording. I see a red dot. I would.
Okay, I don't see that. I was looking for it.
Yeah, I think so. At least I think so.
Okay,
yes.
that's fine.
Yeah. It says that the recording is still alive.
Okay, good. So then with this, I would like to go ahead very quickly. The goal is that to make industrial systems, system here means data, devices, machines, and products. Okay, so let's just call them an element. Actually, I don't have a generalized name for all these things because they vary very, let's say, differently. So we have industrial data that are produced by machines or consumed by machines. We have devices like small devices with sensors, actuators, and so on. We have machines of different complexity and different compositions of other machines or other devices. And we have the products that are produced by these machines. And sometimes the machines themselves are also products. Like a big milling machine can be a product that goes to another factory to do some job. So the first thing is that to actually to find some sort of like naming convention for this kind of thing. But bear with me when I am just talking a system or something like this. So the ultimate goal is that to make industrial systems fair. With this definition of fair, I guess you all know fair about fair on data, but here the idea is that to apply fair on machines and industry. So as you guess, the first is to semantify those things and then to utilize that semantification in accordance with this goal. So we are actually doing semantification of industries for a purpose, and that purpose is going to actually to encourage and improve these fair principles. So with fair in industry, these are just the beginning infant definitions. Hopefully we can actually make them rigid and robust over time. But at the moment is the thing that we have. Let's say, for example, for findability, the definition would be that any data item like sensor data or any data set that is a composition of a data item, or a device, or a machine, or a product, they should be self-descriptive using semantic web standards and supporting technology. It's like that if you have a machine, this machine should be able to express itself. So you don't need to maintain a data set about this in your knowledge system. The data is already built into the machine or into the sensor. Let's say, for example, if you have a small sensor that is measuring the rotation of a motor, this sensor contains semantic description of itself so that you know, for example, what is the maximum velocity or maximum RPM that this sensor can measure, or what is the maximum energy that it uses for its operation, or what is the, let's say, error rate of it at different speeds of measurement and so on. So you don't need to go to a data sheet, you don't need to go to a catalog, you don't need to go to a knowledge base. You can just directly interact with the sensor. This is the matter of findability. And then other devices can actually find you as a device or as a machine so that they know that they are, let's say, placed on a milling machine, or they have been placed on a hydraulic pump or something like this. So when we have the findability, it means that machines and devices can find each other. Then they need to access each other. So in this case, the definition would be any data item or data set and device and machine and product should be accessible to its direct neighbors as well as for remote agents. It's like that if I know that there is a sensor attached to me as a pump, I can ask that to get started when I get started. And I can request a shut off when I'm going down, or vice versa. So this accessibility is also a mechanism to, first of all, to use the features in the findability, and second, to actually to cooperate with each other in a organized way. And then in FAIR, we have I for interoperability. In this case, it means that all those elements that I say, data, dataset, device, machine, and product, should be interoperable within their environment. So it's like that, again, if I install a water pump that is pumping hot water, for example, in this case, it knows that the environment is hot, so it should be able to interact with that, for example, for temperature controller. So you say that I am a water pump. If temperature goes from 80 to 90, my capacity goes down from, for example, 1000 liter per hour to 800 liter per hour. So they can actually interoperate with each other to maximize an optimization objective. And then reusability here is that basically in terms of data and data set, we know what the reusability means, but in terms of material elements like devices, machines, and so on, they can be swappable and replaceable. So it's like that if I know two devices that are semantically equivalent, I should be able to swap them or replace one of them by the other one. So in this case, it's basically like semantic interface to the device properties and device behavior, which actually makes me independent of the physical characteristics and physical limitations. It's like that I have a sensor, I interact with the sensor, then I compare this with another sensor and find out they are equal, semantically equal. So in this case, for me, it would be easy or with high degree of, let's say, reliance on this, I can replace it with another one. This is also a part of the reusability. So this is the goal. Objectives are here that to semantify industrial data and to semantify industrial elements, let's say, like all those stages that I talked about, and then to semantify the industrial communication also with annotation of devices from a structural perspective, from behavioral perspective, their specification, their, I don't know, configuration, their calibration capacities, and so on and so on, so that you have a full semantic counterpart, or let's say it's not really a digital twin, but let's call it a semantic twin. It's a semantic twin of your industrial part. And then using this semantic twin, we can do a lot of things without the need to access the physical element. So that is the objective. Approach here is that to use a reference model, like for example, my suggestion here is to use RAMI as a reference model, and then use of semantic web technology like OWL, RDF, Sparkle, and so on, to apply different ontologies on different locations of the RAMI model. I will show what is this RAMI model in next slide. So the first step would be that to identify which are the good candidate of ontologies to be plugged into RAMI model, and then to specify them in a way that they can model structural, behavioral, communication, interfacing, and this kind of properties of the objects or of the elements or the parts that they are going to model. So with that, we will have a semantic version of RAMI model that we can basically try to start to filter it, start to query it. It will be like an industrial knowledge base of ontologies that you can use it not only for ontology selection, but also for element description, and then to make the elements fair. Okay, let's say that this is RAMI model. This is basically a multi-dimensional model for specifying different things in industry. Like here, if you see my mouse, we have the product, we have field devices, we have control devices, we have stations, work centers, enterprises, and connected world. So it basically goes from the product level up to the factory, and then to interfactory, and then to the globalization of factories. Like that, if you have a product that has been manufactured by multiple factories, possibly you need some sort of communication between them or some sort of agreement between them, and so on. So this is one dimension. The other dimension is this layers here that you see them in different colors, which basically means that from which layer you are looking at your, let's say, assets. In this case, asset actually is a good name. Like for example, if you look at your product from the product itself, or from an integration perspective, or from a communication perspective, or from an information point of view, and so on. So you can actually look at same thing from different perspectives and see differently. It's like that if you look at the communication, it would be important to see how this control device interact with this field device. Like how, for example, your ERP system sends a milling instruction to a machine based on a specification that is developed by your manufacturing or engineering department. So in these cases, communication of data, communication of instructions, and communication of logs, errors, and metrics, and so on could be of the interest. So in this case, we may, for example, say that for control device, in communication layer, we can have this ontology, and this ontology. Or your control system should be specified with this ontology so that it can actually self-introduce itself to an ERP system or to a manufacturing machine, and so on. So this is the general idea that how this RAMI model can help us. The good thing with RAMI model is that it has actually some sort of see traction and acceptance in industry, especially in Europe. So we can actually ride on that horse just by semantifying it, or even semantifying it at one layer or at one level of the devices and manufacturing line, and so on, and then gradually grow up it, or even let other people help us to make it more connected. So look at it as a multi-dimensional, like cube-like. that you can just turn it around like this with those, what are those cubes that people play with them?
Yeah, Rubik's Cube, I think.
Yeah, right. So let's say that you have some requirement, you just turn this and then turn this and then turn this, and then what comes on the surface is the ontologies that you want. So this was just like a very funny analogy. Okay, with this, you see that there are some movements that people are actually translating RAMI model to their requirements. Like here, for example, this digital transformation in product engineering and production. They say, for example, at the product level, we have this device. In the field, we have this. I don't know, in the station, we have that. And then how we are getting them connected to each other. So, for example, here they can say this. This is a message format. I don't know here, this is a protocol, and so on and so on. So we also can create something like this and publish it from time to time, get feedback on this, go to workshops or go to conferences and so on, so that gradually we have like a holistic view of things that you can mix and match them by selecting your requirements, basically. Or this is another one. This is basically a toolbox that you can model with it. So for example, here you say at the asset level, I have this assets, they want to communicate at this topology and so on. And then this model helps you to find out who can talk to whom and possibly with what protocols and so on. So if we have that holistic view of ontologies, specifications, communication standards, and so on, possibly this modeling tools can actually utilize that and exploit that power. Or here, there is a standardization effort requested by China from Germany that they actually paid for this kind of industrialization, so that they also want to come up with some sort of system hierarchy, I don't know, department hierarchy, and then product life cycle and so on, and adapt it for their requirements. So the thing that we are looking for has actually triggered some people, possibly, but we can somehow aggregate and centralize that and also somehow take the credit for that. Okay, here I stopped talking about the model. Before this meeting, I had a conversation with Felix because he's working on a project that intensively is connected to industry and also to semantics and ontology and so on. So Felix, if you want and if you are prepared for this, you can give us some sort of introduction, but I would like to finish this part and then come back to you because I guess I have 2 more slides maximum. So if we can get started and if we can get the ball rolling, this is my suggestion for the first year. Like defining and formulating fair principles, like the definitions that I had are just really rough ideas. They are not really definitions. So in the first year, we may focus on defining those things that what is a fair industry. That would be one thing. And then the second one would be like nomination of ontologies for the asset layer, only for one layer. So in one layer, if I go back to the reference model here, in this asset layer, we have 7 asset levels, let's say. So we can possibly do some desk research and come up with some ontologies to be nominated for this layer, put them together and publish them possibly as a paper or as a white paper or something. And then if we have something like defining those fair definitions and this nominated ontologies, possibly we can host an event or contribute to an event and publish the result. So this, from my perspective, would be a great achievement if we can actually publish something in the first year. With that, I guess I'm done. So if there is anything that we can discuss here, we can do that possibly in like 5 minutes or so. Otherwise, we can listen to Felix and then come back to discussion.
So I would have some well, some remarks or some questions. So the one thing with fair is maybe a bit contradictory to some of the industry application. At least I could think of because mm, I could imagine that there are systems, as you call them in a very broad sense, that would not like to be visible and not like to communicate because of, I don't know, privacy reasons or of because oh, well, I don't know that
Yeah,
there could
I
be so
get your
many.
point. I get
Mm,
your point. There are two
mm,
things. First of all, at the moment, we are not thinking about security and privacy and so on. We say this is possibly the most open thing that everybody is encouraged to do. But then at the same time, we told them if you have a privacy issue or a security issue, you can actually reduce that, or even there are some points that you can extend them for your own purpose. So it's basically like a standard. So there are some statements that are optional. You can just drop them. There are some statements that are mandatory to actually to guarantee some sort of compatibility, and there are even some extension points that I don't have them but you have them, so in that case you can go ahead with those things.
mm,
uh, yeah, this is something that I guess we can do it in a long run,
mm.
but at the moment I don't really see it as a show blocker, let's say.
No, me neither. I just would like to bring it up because I could imagine that industries do not think fair. Let's say they
Mm.
think they are rather driven by I don't know, by financial aspects, by optimization aspects,
Mm.
and so forth. So a little bit different in terms as compared to like research data management or such things. But however, I think it is an interesting
Yeah,
approach that should
one
be
more thing
discussed.
that I would like to stress here is that when we say fair here, it doesn't mean open.
Mm,
Okay, it's like that if you put your machine, you are a machine producer, let's say.
mm,
Again, let's say that come back to that water pump. So you
mm,
have created a water pump that has a lot of intelligence in it and senses a lot of things, and based on that tries to optimize for energy. And now I want to buy this and put it into my product line for something else. So in this case, fair means that this water pump talks to my product line, not to the public.
mm. Yeah,
Okay,
yeah.
so
I yes, I totally I agree, and I see that there is a need for a specification that enables system communication over barriers. Let's say, and industry will have an interest in such a standard. I definitely agree to that. But I just I may it could be critical to apply the whole fair principle because the fair principle is kind of um, yeah, like we want to share data openly, friendly, for the good of the people. And I'm not sure if the industry thinks in the same way. But that's the point.
even with fair on data, basically here I'm using the let's say the abbreviation. The principle is similar, but we have to actually customize it for industry.
Mm,
But even in data, when you say is fair, is not that it's free, and it doesn't mean that it's publicly accessible. So there is always security, licensing, privacy, I don't know, financial aspects involved. So those are, let's say, they are constraints. So from one side, we want to make everything open and well defined, let's say at least. From the other side, these factors try to limit it. So there would be a balance in between.
mm, mm,
Okay,
mm,
so we will find out when the community is getting bigger
mm,
and
mm,
when we have use cases and so on, those requirement or restriction will actually press us
mm,
to come with some solutions or to give more options to the users of this kind of system.
mm. Yeah, so well, I have some slides, Abdelhak and
Mm.
myself, we prepared a little bit so I can show a bit of what we're doing, and that's may be interesting to address this point. But I have two further questions. That is
Sure.
one for clarification. So you introduced RAMI as one standard or specification. And I understand you in the way that you would like to apply RAMI as a kind of a classification schema.
Basically,
Is
as a
correct?
reference,
Mm,
as a reference. So what I would like to say that with this multi-dimensional system is basically we need a multi-dimensional reference because we know that there are management levels, there are control levels, and there are device levels. And then there are life cycles, and also there are standards. Okay, so by combining this, we create some sort of like a multi-dimensional system. What I want to say is that at the cross of each of these dimensions, there is a point which says that, for example, at the integration level, these two devices want to be integrated to each other. So what can I do for integrating them? So this crosses, let's say, in a two-dimensional system. Let's say that these are devices. Okay, we have different devices, and here is the maturity level of the whole system. Like if the device is working, if device can communicate with another device, if device can be integrated with another device. Okay, so here I can say, okay, for integration or for communication of these two devices, I have these two options, like two ontologies. This ontology is based on this standard. This ontology is based on that standard. They can be also different. So what we will see at the end is that the crosscut of all these dimensions that are specified by ontologies. And then if you want to comply with that ontology, you will implement it into the device, not along the device. That's the point.
okay. And so another thing. So what do you expect as the tangible output then, or do you have already an idea or
So I guess at the
of the
end, it
group?
would be like a
Mm,
bigger model. We
mm,
can call it like a multi-dimensional knowledge base.
mm,
That this knowledge base at the first level can help you to find out which ontologies applies to your system.
mm,
And then at the second level, it encourages you to implement those ontologies in your
mm,
system.
mm,
And
mm,
then at the end, it makes you somehow competitive to the others if you support these things. Because if we get like a larger scale traction in the industries, then I guess people will go with a device that can explain itself,
mm,
not a device that is like a dumb device that you have to read a data sheet to be able to operate with.
mm. Yeah, so from my experience with the terminology service, we have faced the problem that there are not so many ontologies out there, for example, for the engineering field, which is a quite interesting field for the industry, I would guess. But yeah, but this is another thing that I could imagine that there could be helpful, that we need to kind of build up a community and to raise awareness for semantic tool stack and how it could help in industry applications and so forth. Because I guess that's something that really have not convincingly taking place by now, that ontologies are applied in industry. So I mean, this group here could kind of do this work to bring industry and ontologies together to seek for use cases as in the work group description already described.
Mm.
I think that would be very good if we could bring in a bit more industry to have a better understanding and to elaborate with them what their cases are, or what their needs and requirements and are. Because I think that is where we run a bit in circles. The industry may have not a good understanding about ontology, semantification, and so forth, and how it could help them. And we, as working with ontology, we may have not the competencies by
Right.
nature for the
I
industry.
guess there are two gaps here in this whole scenario that you explained. First is that the ontology is something outside of the industry, so it's done by some other people that are not in the industry. And second is that the ontology and the knowledge base that is created to actually to realize their requirement is usually like a second-hand problem. Their main problem is to optimize their devices, their machines, to make more money, to do competition and so on. And this knowledge base is not really in their day-to-day operations. It's like that we create a knowledge base for them. Then some people in the engineering department or in the finance department or I don't know, in the research department, they are using this information to do something. But that is in parallel or even with some sort of time lag with the actual production. But what I am trying to say here is that to plug this knowledge into the device and ship it with the device. So when you get an actuator, for example, that opens your door, that already has the knowledge in it. So it says that, for example, I'm a door opener, I can open a door 10 times per minute. I'm consuming this amount of energy, I'm operating on 12 volts only, and so on and so on. So if you connect that to the rest of your home automation, for example, they will automatically reconfigure themselves. So you don't need to do like wiring, I don't know, transformation of electricity and so on and so on. Let's say if we take it into car industry, okay, let's say that you are a mirror production like the side mirrors. You have a small factory that is just building these things. If you plug the structural and behavioral information into your um, side mirrors, when it comes to Volkswagen, for example, the mirror already says that I am a mirror compatible with Volkswagen Tiguan only. I have to be mounted on the left side. I can tilt like 10 degree and I can pan, I don't know, 100 degree and so on. I cannot work in this temperature. I'm not going to warm up myself, or I am warming myself and so on. So in this case, the computer inside the car can actually get this information and start interacting and working with the mirror without real programming even.
Yeah. And last but not least, very briefly, so the industry is, I mean, it's very broad and diverse. Let's say. So will there be a focus on something specific, or is it just open, and is there kind of a, a definition of the scope of industry that we look at?
What I wanted to do here is that to create first a reference knowledge base, let's say, and then create some sort of profiles per industry. It's like that we have something core, which has some ontologies that we for sure know that are, let's say, industry agnostic. And then on top of that, we create profiles for each industry. And when those profiles come in, when we have like a bigger community, and we have industrial partners that they can actually develop something or do some research for us, or they can plug this kind of efforts in their research projects or research proposals. Let's say, for example, now I am writing a research proposal. I know that it's good that I have BMW on board. So I can actually say, okay, I will create a profile for automotive industry, and I will focus only on, I don't know, work centers. So then in terms of 2 years, 3 years, I will have 2, 3 ontologies developed for that part only, and then I can attach them to the automotive industry profile.
Yeah, I That's all interesting and good. I just have some, well, let's say clarification, and I think we need such discussions to
Yeah,
have
sure.
a common understanding about these things. I mean, what immediately came into my mind listening to you. So it is a question: what makes an ontology an industry relevant ontology, or is every ontology relevant for the industry, or is
I
there a
guess one
specific?
important thing is that if that ontology can provide some sort of information regarding that fare with the industrial definition of the fare,
Mm,
and you can plug that into the device that you ship it to your customers,
mm,
so that the customer or the user of your device can actually use that in their programming pipeline, in their automation pipeline, in their optimization pipeline.
mm,
So we are not going to, for example, to collect information about authors or dates and so on. That is like secondary information.
mm,
What for us is important is that what is the structure of this device? Let's say is a sensor or is a machine. Let's say, for example, an engine. You can what's that? You can put together a lot of structural information about the engine, a lot of behavioral information about the engine, and then if you have that behavioral information, it can be automatically transferred to the ECU of the car, and then the ECU knows how to accelerate this engine, or what is the maximum capacity that it can expect from this engine under different conditions. So this kind of information we will be interested in, but as I say, this is just my perspective. Over time, we have to adapt and re-steer, I guess, a lot.
sure, definitely.
Yeah, the matter is that because we go to industrial scenarios, all these things should be really lean because they don't want to collect extra information that is not used. They don't want to pay for it. So there is no need in collecting and putting information into machines and devices that no one is really interested in.
Yeah, definitely. And you know, and another point is, and this is related to community building, is that we would need stable ontologies or metadata
Yeah, right.
schemes, you know, and then high quality and standardization. But okay, this brings me essentially to my slide set. Shall I? Yeah.
Yeah, please go ahead, share them. Stop
Abdelhak,
sharing.
yeah, Abdelhak, shall I go through them, or would you like? Or
Yeah, I think it's a good idea. We can go through the slide.
yes.
Yeah.
So shall I go or you or I
Oh,
can just
you can go if you want,
okay.
and if you want me
Okay.
to add.
Okay. So good. So many thanks to have you here. It's great that you have established the group already. For us, it builds a good basis for our interests, let's say, and for sure we want to support the group targets definition as we have discussed already, and to align with them. And as far as I understand, we can bring in some quite interesting assets, let's say, because so Abdelhak and myself, we come from the SC3 project, which actually works on an ontology for the semiconductor and supply chain area. And this is not a quite new ontology, but it is already an established ontology that was originally created in a project several years back. Well, I have those information on the next slides, by the way. So, but what we can bring in through that project is project partners of big industry, as for instance, Infineon and Bosch. And we could bring in use cases besides the ontology that we actually are working on. So a bit of background information here. I have said something already. So the project name is Semantically Connected Semiconductor Supply Chains, the SC3 project, funded by the European Commission, and this is a CSA action, and therefore we are for sure very interested to come to join this group and to stimulate discussions about industrial ontologies and their application. And as a brief history to kind of prove that we have a long-running interest, not only for only project-wise interest to join this group, is that this ontology and the partners that we bring have quite long a common or joint research work together. The predecessor of the SC3 project is the Productive 4.0 project, a flagship project by the European Commission with 26 million euro funding and 111 participants. So it was a huge, a massive project, and the SC3 now continues the work on that, and there is already new activities to have new joint projects with other industrial partners as well. However, the important outcome of the Productive 4.0 project was the already mentioned digital reference ontology, and that is kind of a lingua franca for digitalizing semiconductor supply chains. So it's a very broad and big ontology, and we actually work on integration of further and different aspects to have a very comprehensive view on semiconductor supply chains. Well, so semiconductor supply chain or production of semiconductor itself is a very complex industry, and therefore there is a need, as we see, for such ontology, specifically because we have very short production cycles and heavy and strong dependencies in between industries to really create the semiconductors, and therefore we need a stable and generic framework to communicate in an unambiguous way between those involved and stakeholders. So the objective of the current project SC3 is therefore to support collaboration in industry and academic stakeholders. We work on the digital reference, on the ontology, but as well on a platform to support the work on the ontology itself through various stakeholder group with different proficiency levels to work on ontologies. I guess this is another interesting fact that we could discuss. That is, we on the one side need the ontology or the knowledge engineers, but essentially is the knowledge that comes from the industry and need to be captured and represented. So we always need lots of different views on the industry and their applications. We have big partners, industry partners in the project, which is Infineon and Bosch, and they are quite keen to join in and to bring in their knowledge use cases and wherever they can support the work of this group here. Well, actually, as we already have discussed a bit about ontologies, we would like to bring in and discuss with you the digital reference ontology to, well, as one part of those ontologies that maybe addresses the RAMI cube and parts of it. And therefore, we first want to prepare a members submission. This is the first step in the standardization. As we can see, in the long run, we envision to have a full standardization of the ontology. But now, for them, as a first step, we would like to prepare a member submission, and the hope is that this group may support us in the work to provide feedback on the ontology itself, but as well on the further process of standardize it. And yes, I wasn't sure if all of you are aware of a member submission. So this is a copy and paste from the W3C website. The member submission is not a real recommendation. That is a standard in the sense of the W3C, but you know, it will have the W3C logo and kind of support behind it. And if it is accepted as a member submission, I think I see it as a first step in a full standardization, because it already was discussed in relevant community and comply to certain quality criteria. Yeah, I mean that's more or less. Oh no, that's it from my side.
Thank you, Felix.
Thank you very much. Interesting. Actually, not only from the ontology perspective, but also from the contribution to the potential contribution to the community group that we are talking about. I'm not deeply familiar with the digital reference, but I just have some, let's say, coarse-grained understanding of it. As you say, this is for supply chain, right? But focusing on industrial supply chains. Is it right?
Yeah. For so in the semiconductor domain, supply chain and management. So it addresses in various domains and aspects in the semiconductor supply chain management.
Okay, one interesting point here would be that if inside this supply chain you model the products also, then you're already touching one of those points in the asset layer.
Yes. So there are many aspects. There is not yet, at least, a full model of a product itself, but rather the processes behind it.
Okay, okay.
But I know that Infineon for especially is quite interested to get more feedback on you know, how they could extend the ontology to make it better applicable. So if the group is interested in more detail in the ontology, I would propose to invite one of those ontology creators, because I'm not one of those. I have not an absolute detailed understanding about the ontology itself, but rather on its necessity and where to apply it.
Okay, good. I guess in this case, it would be a good candidate to have a product definition for semiconductor industry at the asset level, and we can model it as a profile, not as part of the core, because in core, I guess we will have like more generic product definition, and then it would be a specific profile for semiconductor industry. And because you are running the project, possibly in that one first year that I just talked about it, we can come up with some solutions or some suggestion at least for how to model or what would be a good ontology for product specification in semiconductor industry, and then we can plug it into our model there.
Yeah, I mean that would be very appreciated. That would be. I mean, I think it's. I understand that this group. So in a way that everyone will bring in something, and that the group will discuss this and support various or reject
Right. Yeah.
things to to have a lively discussion, and that hopefully brings us to some tangible outputs.
Okay, great.
Because I think standardization that comes out of the group would be a very tangible output,
Yeah,
right?
that's right. Yeah. Okay, great. Thank you. Anything from you, Abdelhak?
No, essentially that was the different points that we wanted to talk about.
Mm-hmm.
So yeah.
Okay, great. Thank you. So I guess I will make a summarization of this meeting and publish it on the group community website. Possibly attach the video also to it and the slides.
Mm-hmm.
And if you are okay, I can also publish it on some other channels like Twitter channel or I don't know, YouTube and so on.
It
Just
would
to get
be, yes, that would be great. At least from my point, Abdelhak, you can the word to say, but I would really much appreciate if you distribute it wherever.
Okay, great.
I also agree. Yes, Felix. Absolutely.
Good.
And we could
Thank you.
reference the video.
Okay,
Good.
great. Thank you very much. Thank you for participating in this very first kickoff.
Good.
Let's see where we get in 1 year.
Yeah, let's see. So just one further question. So will you organize a follow-up meeting?
Yeah, sure. I will actually publish these things and publish
Mm-hmm.
it by sending some sort of like a newsletter to the group.
Yep.
See if there is any reaction, and based on that, I would much like to have like quarterly meeting at least.
Mm-hmm. Yeah, super.
But let's see if I get any reaction.
Okay. Okay, good.
Okay.
Great.
Yeah.
Okay.
Perfect.
Thank you very much.
Thanks,
Have a
Javad.
great evening
Same
and
Thank you.
good weekend.
Bye
Bye.
bye.
Thank you. Bye bye.